Hello my dear friends, good morning and welcome to this new class. And we are studying about the climate of India, and as we had already said, different parts of India experience different types of climates. Some places is very dry, some places it is cool, some places too hot during the day, some places too cold during the night, and some places, especially the coastal regions and so on, is more or less same climate during the day and night and so on. So we experience different climates, and we saw all these climate changes are experienced because of the presence of wind. The wind blows from high pressure area to the low pressure area. That way the movement of the air it is causing. And we saw some are moving in the ground level, some are moving in the high level. All that is affecting the climate of that place. So another special character of Indian climate is the monsoon. Indian monsoon. That is what we are going to study today. We can follow in your textbook, page number 28. The Indian monsoon. So the climate of India is strongly influenced by monsoon wind. So we call it monsoon rain. This is the time usually we get monsoon rain. From the month of June onwards we get monsoon rain. So this monsoon rain we get because of monsoon wind that is blowing from the ocean, from the South India to the North India. The wind moves. Afterwards the wind will be returning back again. So that is called monsoon wind, and these winds are laden with moisture as they are coming from the hot sea. The wind is carrying a lot of moisture, and as they pass over India, the moisture is coming down as precipitation, as rain. That is how we get this rain. So the sailors who came to India in historic times. So you might have studied in the history how Vasco da Gama came to India, or other Portuguese people or British people. They all came to India those days through sea, because there was no roadway, no airway and so on. They had to take months and months to travel through the sea and reach here. And they were depending on the wind. They will be tying the ship, right? And the wind comes, it will be pushing the ship. That is how they were traveling. So rowing with the hand is not possible for such a long time, such a long distance. The movement will be very slow. But when the wind is favoring them, the wind is blowing in the same direction that they want to go, the ship will be moving faster. That is how they realize that there is a wind direction is there in this region. And they benefited from the reversal of the wind system as they came by sailing ships at the mercy of wind. So these people were completely depending on the mercy of the wind. If the wind was not there, then they would not have reached here in time. They might have taken years to reach here if the wind was not there. And for their luck, you can say, the wind was there, and they made use that force of the wind, and they reached their destination. So the Arab people who had also came to India as traders named this seasonal reversal of the wind system monsoon. You can underline. So this wind system that helped these traders, it was experienced by the Arab people, and they were the one who to name this wind as monsoon wind. So the name was given to this wind by the Arab people. And the monsoon experience in the tropical area roughly between 20° north and 20° south. To understand the mechanism of the monsoon, the following facts are important. So the area where this monsoon is experienced is the tropical area. I hope you remember we were talking about tropical region in the last class. So from the equator On top, in the northern hemisphere, there is a Tropic of Cancer is passing through. That is passing through somewhere in the middle of India. Then below the equator, there is another tropic is a, that is Tropic of Capricorn. So between these two tropics, that is the area normally experienced by this monsoon. And in order to understand this monsoon in a better way, we have to learn about certain wind that is blowing in this region. And first one is the differential heating and cooling of land and water. So you know already that fact, that land and water, they are not getting heated up equal. The land becomes hot very fast, but the land is becoming hot slow. The water is getting heated slowly. But afterwards, when the night comes, the land will become cool very fast, but water will become cool very slow. So that is called differential heating and cooling of land and water. So land becomes hot very fast, but water is taking time. And that creates low pressure on the landmass of India, while the seas around experience comparatively high pressure. So when the land is cool, the water is hot. So in the land there will be high pressure, and in the water there will be high pressure, and in the land there will be low pressure. So that that makes the passing of the wind or the flowing of the wind because of different temperature. In the land one temperature, and the water another temperature. Water level is high and the land temperature is low. Then another thing is the shift of the position of Intertropical Convergence Zone. So there is a zone called an area where the wind is blowing, but that is shifted sometimes. There is the usual flowing of the wind, one region is there, that is called Intertropical Convergence Zone. Many wind come and converge. So that zone is sometimes changed. So in summer, over the Ganga plain, and also known as monsoon trough during this monsoon season. So normally it is supposed to be positioned about 5 degrees north of the equator. So this position called Intertropical Convergence Zone, it is just 5 degrees above the equator. But sometimes it is going higher and it is reaching over the Ganga plains, the northern plains in India. So it goes up to there. So it is changing now and then. Normal position or normal area is just close to equator, just 5 degrees above the equator, that is in the northern hemisphere. But sometimes it is going higher. It is reaching up to India, especially to the Ganga plains. So that is also causing the change, causing or affecting the monsoon. So it is normally known as the monsoon trough during the monsoon season. So during this monsoon season, this wind is blowing in this region, and that area is known as monsoon trough. Then the third thing is the presence of high pressure area east of Madagascar. So there is a presence of high pressure area east of Madagascar. So approximately at 20 degrees south over the Indian Ocean. So this high pressure area east of Madagascar, that is in the Indian Ocean, 20 degrees south of Indian Ocean. And the intensity and position of this high pressure area. So there is a high pressure and that affects the Indian monsoon. So that is the third thing that is affecting monsoon. Then the fourth thing that is affecting monsoon is the Tibetan Plateau gets intensely heated during summer. You know the Tibetan delta, just above the Himalaya, the Tibetan is there. So that plateau gets highly heated during the summer season, and which results in strong vertical air currents. Area affects the Indian pressure. So that high pressure overplay at around 9 km above the sea level. So when there is the Tibetan plateau is getting heated up, so you know where it is heated up, that area will have high temperature, high pressure, and so air will start blowing from there to another place. So here the Tibetan plate is high and it is 9 kilometers above the sea level. So from there air starts moving. So 9 kilometers high. That means it will come even above the Himalaya and so on. So it is because of the Tibetan plate is getting heated up and the air starts moving about 9 kilometers above sea level. And the fifth thing that is affecting the Indian monsoon is the movement of the westerly jet stream to the north of the Himalayas and the presence of the tropical easterly jet stream over the Indian peninsula during summer. So during summer there are two types of winds moving, we already said earlier. So there is a easterly wind and there is a westerly wind. East jet stream and east jet stream and west jet stream. So these move in different directions. The north of the Himalayas and another one is over the Indian peninsula. So because of this also the monsoon in India is affected. What is it? The movement of the westerly stream to the north of the Himalayas. It is moving to the north of the Himalayas. Then another wind called tropical easterly jet stream that is moving over the Indian peninsula. So two winds are moving in two directions, and that is also happening during the summer, and therefore that is affecting this monsoon. And let's see. Earlier we said about Intertropical Convergence Zone. We said there is a convergence zone just above the equator, 5 degrees north of the northern hemisphere. Let us see a little bit detail about what is this Intertropical Convergence Zone. So the Intertropical Convergence Zone, in short form it is called ITCZ. So it is a broad trough of low pressure in equatorial latitudes. So it is a low pressure area along the equatorial latitude. Then this is where the northeast and the southeast trade winds converge. So these two winds, one is the northeast, another one is the southeast. So the wind that is coming towards northeast and another wind that is coming towards the southeast, they come and converge, they come and join together. And this convergence zone lies more or less parallel to the equator. So it is just near to the equator, in parallel to the same line with the equator, and moves north or south with the apparent movement of the sun. So afterwards it will just both winds will meet together just close to parallel to the equator. Afterwards it can move to the north also, or it can move to the south also. It depends on the apparent movement of the sun. That's why sometimes we said it reaches to the north, that is to the Ganga plain, Ganges. It reaches to the Ganges. Sometimes it also moves to the south. So because of this change of convergence zone, we see the monsoon happens, monsoon system happens. Then apart from this, there are also some other movement of the winds are there which is affecting the monsoon. Let's see what are they. So apart from this, it has also been noticed changes in the pressure conditions over southern oceans also affect the monsoon. So in the southern oceans, there also some pressure difference is there, that also is affecting the monsoon. So normally when the tropical eastern South Pacific Ocean experiences high pressure, so when there is high pressure in the Indian Ocean, in the south of the eastern and southern part of the Pacific Ocean, when there is high pressure, the tropical eastern Indian Ocean experiences low pressure. So when one part of the Pacific Ocean experiences high pressure, other part of the Indian Ocean is experiencing low pressure. You know what will happen if one place there is high pressure, another place there is low pressure. The wind will start blowing from high pressure area to the low pressure area. So it is in two areas. One is in the high pressure is in the Pacific Ocean, the low pressure is in the Indian Ocean. So, but in certain years, there is a reversal in the pressure conditions and the Eastern Pacific has lower pressure and in comparison to the Eastern Indian Ocean. So normally what happens is the Pacific Ocean, the east and the south part of the Pacific Ocean high pressure. But sometimes it happens just the opposite. The Indian Ocean will have high pressure and the Pacific Ocean will have low pressure. So before the wind was blowing from Pacific Ocean to Indian Ocean. But when the Indian Ocean will have high pressure, the wind will start blowing from there to the Pacific Ocean. So the reversal is taking place. And this periodic change in pressure condition is known as southern oscillation. So it has got a special name, we can underline. So this reversal of wind, normal change in flow of wind is from Pacific Ocean to Indian Ocean. But sometimes it is changing from and blowing from Indian Ocean to Pacific Ocean. So this periodic change, at a certain period this will be changing, and that is called southern oscillation, or in short form it is called SO, southern oscillation. Then the difference in pressure over Tahiti, that is in Pacific Ocean. So the difference in pressure over Tahiti and Darwin in northern Australia, that is in Indian Ocean. So we said about these two spots, one spot in Pacific Ocean, another spot in Indian Ocean, where they experience high pressure and low pressure. So these 2 points is computed to perfect the intensity of the monsoon. So we can, by calculating the pressure of this Atlantic Ocean and the pressure in the Indian Ocean, by calculating them we can find out how strong this monsoon will be. So if the pressure difference was negative, it would mean below average and late monsoon. So if you calculate the pressure of the air and realize the calculation is going to minus, then we can see that year the monsoon will be very low. They will not get very strong monsoon rain, and it also may come very late. It will not start in normal time. So that by measuring the pressure of the wind, we can predict the monsoon that is going to happen. That is how those who are forecasting the weather and so on, they are able to predict this year when will the monsoon start. Will it start in time or will it be strong and so on. Then if the pressure difference were negative, it would be below average and late monsoon. And a feature connected with the SO, that is southern oscillations, is the El Nino. So another system or another wind, that is called El Nino, that is also connected with this southern oscillation. Let us see how they are connected. So El Nino is a warm ocean current that flows pass the Peruvian coast in place of cold Peruvian current every 2 to 5 years. So there is a cold wind that is blowing along the Peruvian coast. And after 2 to 5 years, sometimes it is changing. So normally it is a cold current that is flowing along the Peruvian coast. But sometime after 2 years, or sometime after 3, or sometime after 4 or 5 years, this cold wind becomes hot. It becomes a warm current. So there is a change in a few years, not every year, sometime after 2 or 3 or 4 or 5 years. So once in a while, the cold wind becomes hot wind, or the pressure becomes high. It becomes a warm wind, warm current. So the changes in pressure conditions are connected to the El Nino. So why? Sometimes it is a very cold wind and sometimes it is a very hot wind. Why? It is all because of this El Nino, the wind called El Nino. So hence the phenomenon is referred to as ENSO. So for we said SO, Southern Oscillations. So SO, and this one, another one is N Nilo, El Nino. So in order to put them together, we can say El Nino and Southern Oscillations. So together we can say ENSO. That is a short form of two phenomena. One is Southern Oscillation. What is Southern Oscillation? It is a periodic change in the condition of the wind. We said from the Pacific Ocean the wind is blowing to Indian Ocean, and sometimes it is reversing. From Indian Ocean it is blowing to Pacific Ocean. So that periodic change is called Southern Oscillation. SO. Then another one is El Nino. That is the wind that is blowing in the Peruvian coast. Sometimes normally it is a warm current. It is a warm current. But after a gap, or after 2 years or 3 years, or even after 4 to 5 years, suddenly this warm current becomes a cold current. So there is a change of temperature. That is called El Nino. So together we call it ENSO. El Nino and Southern Oscillation is put together. So that is called El Nino. Now let us see a little bit more about El Nino. So this is a name given to the periodic development of a warm ocean current along the coast of Peru as a temporary replacement of the old Peruvian current. So El Nino, we already said, it is a warm current, but it is replaced by a cold wind. And El Nino is a Spanish word meaning the child. So El Nino, it is a word taken from Spanish language, and the meaning is the child. El Nino means the child, and refers to the baby Christ. So why they call it the child? They are referring to the baby Jesus, baby Christ. As this current starts flowing during Christmas season. So Christmas is a season where people celebrate the birth of Christ. So this wind also is starting in this Christmas season. Therefore, they gave the name, the child, to the stream, El Nino. So the presence of El Nino leads to an increase in the sea surface temperatures and weakening of the trade winds in the region. So because of this El Nino wind, what happens? The sea surface temperatures are increase in the sea surface temperature. So this hot wind, when it is a warm current, it is increasing the sea surface temperature, and it makes another trade winds in this region, making it weaker. So these are the different types of winds that is affecting affecting the monsoon or deciding the monsoon of our country. So you need to read this text again and again, learn the names, different terms, the winds, different wind directions from where it is blowing to where, and so all that you have to study nicely. So we shall wind up today. We will meet again tomorrow and discuss more about the monsoon rain. So thank you for listening. Have a nice day.